full room. And what a great job the team has done. Everyone's been working really hard on this. I want to say a couple things before I go any further. There we go. I want to a big thank you to our speakers, our demo partners, the volunteers, and everyone who made this event possible. I want to let you know that there is an event coming up, and it will be hosted in connection with the Connectivity Week conference, which is occurring at the Santa Clara Convention Center on May 23rd. It's called Smart Grid Standard Soup. It's an update on the status of the smart grid industry. I encourage you all to attend. We have a discount code available on the WCA website. If you want to register for the conference, you can get a discount by using the code we've placed on our website, which is, of course, wca.org. We have an app on Android. You can download from the Android market a WCA app. It has some a portal to certain information, which can help you find out what we're doing. It has a link to our Twitter feed. Twitter, Facebook, and all the photo gallery is all in the app. I want to mention that our Facebook fan page is facebook.com/WCA.org. We're also WCA.org on Twitter. If you prefer social to the mailing list, please join us online on our social channels. And I want to mention that we are forming a semiconductor SIG in the WCA. So we are going to form a separate group which is going to deal with semiconductors. If you're interested in being part of the WCA Semiconductor SIG, please come talk to me or look for anybody that has a plastic badge with the WCA logo on it. That'll be a board member, and we can talk to you about setting an agenda on that first SIG event. Without further ado, I would like to introduce Tristan Jew. Tristan is one of our newest board members of the WCA. We're very pleased to have him be part of the organization. He's done a fantastic job on this event. If you haven't met Tristan, I encourage you to say hi to him afterwards. And he's going to take it away, and thank you all for coming. Tristan Jew.
Thank you, David. Wow, what a turnout. We have a fantastic show for you guys to enjoy tonight. I would like to call this a show rather than an event. We've got a tremendous set of partners and sponsors supporting us at our event. We do have a very tight timeline. As you can see here, today's agenda is quite tight. We're already a few minutes behind in our presentation section here. We're going to try to wrap up as close to 8:15 our main presentations with a short break in between. Sensors, which are basically ambient light and color sensors, and end with environmental sensors, which are basically temperature, humidity sensors, and pressure sensors. Okay. All right. Okay. So is this better? Yeah. Sorry about that, folks. So we're going to talk about these four red categorical sensor categories tonight by our presenters. And those sensors that are highlighted in star marks are future sensors, commercialized out in 2015 timeframe. Okay, and there's other sensors like besides the wireless RF sensors that we're very used to seeing. We have other sensors such as MEMS microphone, biometric fingerprint sensors, or biosensors. All right. With that, I'm going to before we launch into the actual presentation session, we're going to share with you some market statistics that might be of interest to you. In terms of the outlook for mobile sensors that go into mobile handsets, you can see that the way to read this chart is the blue bars down below are smartphones, basically, in terms of number of unit shipments, millions of unit shipments. The red bars are basic and feature phones, basically non-smartphones. And you can see a healthy growth rate for the overall mobile phone market. Designated in lines here, in different colors, are sensors. And these are represented in the right column here in terms of percentage penetration rate into these mobile handsets, and all across both smartphones and feature phones. And as you can see, these among the popular sensors, the motion sensors like accelerometer, compass, and namely cameras that are 3 megapixels and above, high resolution cameras, are well above 50% penetrated by 2015. So, the era is here. We're standing right here, right between 2012 here, where we're just barely in their 40%, 30% penetration rate. But the good news is that these sensors are just beginning to pick up in terms of adoption rates. Now, here's another stat for you that might be of interest. The reason I asked how many apps developers are in the audience is that if you take these type of sensors and look across these 3 main platforms here, Google Android, iPhone, and Windows, and look across the app stores and do a simple search based on sensors. These are search terms, simply, just going into these apps, motion, or accelerometer, or gyro, or proximity sensors. You actually end up with quite a low number of hits, basically. Out of 470,000 plus apps in Google Play, 600,000 plus apps in iPhone App Store, and 82,000 plus apps in Windows Marketplace, there's less than 0.5% share of these apps that are actually meaningfully using sensors. And today, as you saw earlier in the slide, sensors are already here today, ready to go and be used to differentiate your user experience. And these numbers are actually the number of actual apps that are using these sensors. You can see that there's rarely anything above 1,000 out of these hundreds of thousands of apps that are using sensors. And hence our event, to get everyone excited about the sensors and really learn how to utilize them in your user experience differentiation. With that, I'm going to now launch us into the main presentation session. I'm the moderator for tonight. I'm one of the board members, and I chair the Mobile Special Interest Group for WCA. I'm currently independently consulting. I've been in the wireless and mobile industry all my 16 years of career. For those of you who have received our event flyer, there's bios for all of our presenters and myself in the back, so I won't belabor going over my background. But without further ado, I would like to introduce you to our first speaker of the night, Wen Lin from STMicroelectronics, talking about motion sensors.
Thank you, Tristan and WCA, to give STMicro and myself this opportunity to present tonight. And so first, a quick introduction for STMicro. And we have 5 major product groups, and basically it's multimedia and ASIC, microcontroller, and also discrete and integrated power device. And the other group is the analog IC and also the main group. So these are the 5 major product groups, and I'm working in the main group. And we are targeting these 5 major markets, and with automotive, communication, computer and peripheral, consumer, and the industry. And what we are looking at is the major applications in smart consumer device, healthcare, trust and data security, and energy management. So STMicroelectronics is a multi-international company, and we have about $10 billion revenue yearly, and also we have about 50,000 people worldwide. That's a quick intro for ST. And for the group I'm working in, and this is the men's group, and which we are very fortunate and very honored to be the first, the #1 in this market, and for the consumer and the mobile communication application. And just to give you some numbers, and last year, 2011, this is I supply number. 2011, the whole market grew 420 million, and the ST grew 300 million plus. So we are very happy about that. And why is that? And one reason is ST has heavily invested in the sensor since starting from the beginning, 2002, 2003. And these are the family of the products packaging from the beginning. Now pretty much the parts is between 4.4 millimeter to 2.2 millimeter type of range. And it doesn't matter about whether it's a gyro, accelerometer, or combo type of devices. And while the differentiation to ST with in the market is basically we are fully integrated company. We have the production design and all the way front-end packaging, front-end design, back-end packaging, and all this, and also we control the whole process. So we are very flexible to put the product out there. So let's just go straight into the application. What you see today. So this space of the today, pretty much you can see a lot of sensors in all these devices. And for example, the accelerometer in the phone, tablet, MP3 player, even the screen is small. But if you can use the screen detection feature to maximize the usable area, it is still better than nothing. Okay. So, and that is nature for the for HDD protection in the notebook, and compass, gyroscope for gaming. So this is what you see, very typical type of application in the devices today. What are we going to see next? Okay. And this is indoor, outdoor navigation. This is one of the key driving application, killer application we are seeing today. And this is being heavily invested, and the infrastructure is getting there, and the sensor pricing size is getting into the right mix. Okay. So what is going to give us the navigation feature, and on the application side, is actually give us the location-based type of services. Okay. And I think maybe some of you have seen the Google glasses. Okay, that's kind of interesting, and a lot of parody type of things also showing on the YouTube. But basically, this gives us the freedom of have this kind of technology. And in the later slides, I will show you how this is being accomplished with our motion and orientation sensor as part of. So sensors, accelerometer give you the acceleration linear acceleration information. Magnetometer give you the heading information. Gyroscope give you the angular rate information. Individually, it gives you a lot of information for your application. And what are the driving technology today to enable us for the next level of the applications? So one of the things here, the key driving factor is the sensor fusion. And what the sensor fusion gives us first is a standard software interface. So for the application developers, they no longer need to go down to the sensor hardware level to control individual sensors, program individual sensors, and they can just look at the output quaternion, heading information, pitch, yaw, and roll, and the linear acceleration and the gravity. And with that information, it's easier for software developer to do their work. And the other thing is, more importantly, is each sensor has deficiency. So with multiple sensors, give us more accurate and a more reliable output by combining all these sensors. Okay, that's a very key item that's the reason why it is usable for the location-based type of service in the future. If you have inaccurate output, then you are completely lost. And keep on going. So the other area of the advancement is not only modularize the sensor output at the sensor API level, and individually on the SoC development. And today, there
Right now, there are dogs barking in Sacramento.
It's okay? Yes, it's okay. So, okay. So the other area of the advancement is for different SoC, and for this kind of we are talking about a sensor hub now, and basically it create further modularized solutions, and with these modularized solutions, basically the driver being written in the software stack for the SoC, you can reuse this software stack on different environment, different SoC environment. So this further modularizes the sensors, and all you need is a sensor hub to control individual sensors. And what it gives us is a plug and play. It's just like a mouse type of device. You really don't care whose mouse is, you don't really care about hardware. You only care about the data. And the other thing is to give us further power management type of features, so you can improve detections and gesture recognitions, all type of interrupt treatment type of solutions in this micro. So I just like to use this, go back to the indoor navigation and also location-based type of service information, and why we want to do that. And many of us in the convention center, in the corporate campus, and we are looking for the event, we are looking for the show. And if we can just so easy to figure out where we are now, and we key in the destination, the location, and we can go there directly instead of wandering around and tired the whole day. Okay. So there are many usage, and also in the corporation security type of environment. With a notebook, if you want to keep the system inside of the facility, and you can have this feature enabled. If it's outside, going outside of the facility will trigger the alarm. So there are many type of opportunities here. How this is being implemented, and this is all using the sensor along with the GPS and also Wi-Fi access point triangulation information. So basically, in the outdoor environment, we have GPS, but once we can use the GPS to calibrate the potometer features, we can calibrate how the strike length, those kind of as a calibration, and also with the pressure sensor, just example with the barometric pressure, you can figure out which elevation, which floor you are on. Okay. And once you get in the indoor, you have a Wi-Fi triangulation. You have Wi-Fi information. The more Wi-Fi, you get the more accurate information. And then you, with that, you get a rough range of where you are. And then in between the Wi-Fi splitting, okay, you can use the accelerometer and along with the gyro as a pedometer type of feature with a compass for the heading information. So this is how it is accomplished with the navigation. So this is the last presentation slides, and ST like to show you this as actually as a three-dimensional way of using the sensors. And there are many combinations of the sensor, and the gentleman over there we will cover most of them. But with the combination of sensor input through a gateway, okay, and either this can be an embedded application, or this can be, the processing can be done on the mobile phone, or the data actually can go up higher level. So the data can be analyzed for the health applications, e-shopping, Facebook, where your friends are, and there are many interesting applications we are seeing happening today. And I'm hoping you will be interested about this kind of applications, and also if you have interest in this, don't hesitate to contact STMicroelectronics.
Are these on your website?
Some of this is on website. If you need any information, please just contact me, and we have local sales to cover that. And a quick thing is I want to show you a demo. This is a teapot demo, and basically show you two major things here. One is use the different sensor fusion feature, and then the other one is show you what happens if I disable the sensor fusion, and when the device is interfered by the external magnetic field. So this is a very quick demo. Okay, I have an evaluation board over here. This is our standard evaluation board. I think we are trying here to switch the screen. So basically here I have a teapot demo, and the first I'd like to show you this one. Okay, this is the first green tab is showing that I'm using the accelerometer and the compass to do the demo. And with the accelerometer and the compass, and you can see the magnetic sensing is not that responsive. Okay, and because the sensor will take some time to acquire the signal. The second demo is using the accelerometer and the gyro. And the gyro gives you the angular rate information. So this is a very fast response. And that's the reason you can use this for gaming type of application. However, the angular rate, and there are errors accumulated through the integration. So eventually we'll lose the true orientation. And this is the third demo with all three devices, and this help to not only have a fast response time, but also the true heading information. Okay, so I think the time's up, and thank you very much. And the Q&A will be after, or?
Yes, if people have a quick question, just one quick question or two quick questions, we can do them.
Yeah, will you integrate all the hardware yet on one device in the future? So
So we have today have like a humidity with the ceramic integration together.
We can't hear the answer.
Okay, fine.
The question is about the integration of the sensors. And yes, the answer is yes. And today we have already integrated a ceramic gyro in one package. And also we have a ceramic compass in one package. And we are integrating all three devices together. And in the future we have more integration plan. Any other question? Can we get the eval? Can you get the eval board? So we have distributor, Aero, and the DGK. So you can get the eval board from those companies. Oh, it costs something. Okay. It doesn't cost something, it's not worth it. Any other question?
I think with that, I think due to time restrictions here, if you have any.
Thank you, Tristan. Good evening. Thanks for having me. I'm going to talk to you guys a little bit about touch, give you a little bit of an agenda. I'll tell you first a little bit of an overview about Cypress. We'll go into what is capacitive sensing, why is it exploding, why do people want it, how can you use it. I will tell you a little bit about the competing technologies and why projected capacitive is better and what it's doing for you. Talk about the different types of PCAP. I'll introduce you to some new products and show how some advanced features are sort of changing the game in capacitive sensing, what you guys can do with those. All in 14 minutes, 24 seconds and counting. So a little bit about Cypress. We've got 3,700 employees. We're located here in the Bay. Last year we did about $1 billion in revenue. So things are going well. Our user interface business unit, which is the one I'm a part of, I lead our TrueTouch product. We do all kinds of cool stuff. TrueTouch, which is capacitive sensing. CapSense, which are your button, slider, wheel type products. You'll see those on your DVD players, Blu-ray players, things like that. Trackpad. And finally, finger navigation, optical finger navigation, which we have in quite a few mobile phones out there. So that's kind of the high level of what are the different product lines we have. But I want to kind of hop into some more meat, so let's keep moving. I assume we all know capacitive sensing is just exploding. It seems like just yesterday, no one had ever heard of it. This was like 2007, about 5 years ago. And all of a sudden, it's just exploded. Last year, mobile phones, we shipped, what, 1.5 billion mobile phones worldwide. About 500 million of them were touch-enabled. By the time you get to 2015, about 1.5 billion mobile phones are going to be touch-enabled, capacitive touch-enabled. It's absolutely staggering when you think of it. 1 billion of anything is just a ridiculous amount. That's a lot of packaging going to landfills. So anyhow, nonetheless, it's amazing how much we consume as a world, and it's going to continue to grow. So this is a really important and pervasive technology. So what are some of the other types of technologies we've seen out there? The first touch that you really saw being pervasive in mobile phones was resistive touch technology. Probably all of you guys remember having a mobile phone. You probably had a stylus. You were pointing in all the different areas of the screen when you booted it up, and probably every 30 times you booted it up, you had to do that so it could be calibrated properly. That's resistive. Resistive is interesting because it's made with 2 layers of ITO, so it's actually got 2 sensor layers. What happens is those 2 sensor layers are physically split by a spacer. All of this is optically clear, so if you shift it this way, you can look right through it. But what happens is when you press, those 2 sensor layers get pushed together. We're able to sense that, or resistive guys are able to sense that, and we're able to sense a point. It's not great for multi-touch, though there are some resistive multi-touch solutions. You physically have to press. So in terms of how much did it really take off, how big did it get, it made some good market penetration, but it's absolutely dwarfed compared to capacitive. A couple other things in capacitive. Surface capacitive. Interesting technology, very different than projected capacitive. What surface capacitive is you actually put a voltage into 4 corners of the screen. Assume you got this sensor that lays over the screen. It's optically clear. You drive a voltage into each corner. When you press, you take a little bit of current into your finger, right? And that little bit of current is coming from those 4 corners. A chip that runs it is able to sense it and see it and figure out where you're at. It's really good for single finger, not so good for multi-finger. Lots of issues. You'll see it in things like point-of-sale terminals, big screens where you just got to press one big button, not something really perfect and fine. So not pervasive into mobile. Resistive, actually, one thing I didn't mention, some of the downfalls. What are the downfalls of those 2 layers with a spacer? Light is one of the worst, right? Very little light through. A lot of times, not only do 2 layers actually hurt the amount of transmissivity, but with that air gap, you actually have light hitting the first layer, deflecting, hitting the next layer, and sometimes coming back to the display. So you get a dimmer display. So for these beautiful, bright, OLED and so on type brilliant displays, you really want projected capacitive. Next thing we see a lot of, and this is more in the monitor space, is going to be optical. A lot of people are talking about optical. What you'll see in the monitor space is you'll see cameras mounted in the corners. You've got to have a bezel now on your product to be able to hide those cameras and have those cameras physically see your screen and figure out your positioning. So what does projected capacitive offer over all of that? Well, it gives you the ability to do true multi-touch. It gives you the ability to have very precise measurements down to 0.2 millimeter type accuracy. And it gives you the ability to do gesturing, and all with a nice, sleek, top-level piece of glass, right? So you have that kind of perfect, clean front to your phones. Probably many of you have one now. How many of you guys have a touchscreen phone? I love it. All right, let's keep moving. So, how does projected capacitive work? Why is it called projected capacitive? Actually, what's up happening, I think I got a little leak right here. Perfect. What's up happening is in your sensor, there's all these different layers. There's TX, there's RX. That's transmit and receive. So what the chip actually does is the chip will send a square wave out on transmit lines. Where the TX and the RX cross, you actually form a parallel plate capacitor. Now, the value of that capacitance is both determined by the finger, if it's there or not, and of course, C equals epsilon naught A over D, the area of that cross intersection. So what you see here is when you TX, the way charge physically goes from transmit to receive is it jumps through an E field. So we send the square wave out, it hits the TX side, and it physically jumps through the electric field over to the RX side, and then it goes back to the chip. Well, we can store all the data for every little intersection across the screen, might be a few hundred physical sensor locations across your screen. We can store all that data. Well, when your finger comes and touches, what ends up happening is your finger's got some capacitance. You can see the capacitance here coupled. What ends up really happening is all that TX, instead of just jumping across into the RX side, actually some of that E field gets stolen through your finger. So you actually steal some of the charge. So when all that charge comes back to the chip and we integrate in the chip, you're not going to integrate to the same level because some of that charge was stolen. That's the real basics of capacitive sensing. So what you see here is we might be measuring a mutual capacitance in a steady state of about a picofarad. It's really tiny, really tiny. Maybe a puff. When you touch, we measure 0.9 puffs. So you're talking about 1/10 of a puff, just a tiny amount of capacitance that we're sensing. It's absolutely extraordinary, amazing physics. But that's the basics of how it works. You actually are getting electrocuted when you touch your phones. Not really, but gives you an idea. There are 2 types of projected capacitance. The first is self, the second is mutual. In self-capacitance, every one of these lines is its own sensor, okay? What's nice about that is you get a lot of signal because they're big lines. What's bad about that is something called ghosting. And this is what the first touchscreen controllers did. So if you look at it, if I touch in these 2 locations, what a self-capacitance sensor will say is, oh, Y0, Y2, X3, and X1 are all touched. And you got to figure out what the combination is. Unfortunately, you don't know if it's the 2 X's or the 2 blue dots. That's ghosting. That's self-capacitance. Great because it's got lots of signal, it's robust against noise, works in lots of environments. Bad because we want more than 2 touch. So mutual capacitance looks at the intersection of every one of these. That's that TX crossing the RX. With mutual capacitance, I can discern out the two guys here separately because I'm physically sensing intersections rather than lines, which is great, but I get less signal. Because why? Capacitance is epsilon naught A over D. The area of that intersection is really tiny, so the amount of capacitance I get is really small. Over here, the area is a big long line, lots of signal. So, lots of signal good, less signal but multi-touch. Kind of real basic differences. So I'll come back to that in the next slide. I just want to tell you guys about something cool that's out. We just launched Gen 4. It's a big deal. It's absolutely changing things in the mobile space. Probably the biggest thing, the campaign, was rise above the noise. And the reason we said that is the biggest challenge facing mobile phone developers is noise. Whether it's chargers you plug in, I'm not sure how many of you bought a charger off of eBay or something for $9.99. You plug it in, you try to use your phone, it doesn't operate as well as you might have when you weren't charging. That's actually a big problem. It's called charger noise. Displays create a lot of noise. We do a lot of engineering stuff to mitigate display noise. Gen 4 was all about rising above the noise and eradicating noise in systems. Lots of technical details we can talk about offline, but pretty exciting. But it does something really unique. It does both self and mutual capacitance in the same chip. Switches dynamically between the two, so you can get the best of both worlds. So why is that important? This is why it's important. Advanced features. What's new coming to mobile phones that capacitive sensing is enabling? One, waterproofing. Full IP67 compliant waterproof phones already on the market. You can buy them today. You can drop them in a cup of water, pull it out, use it, no issues, no problems. How many of you have tried to use your phone with wet hands? Does it work as well as you're used to using it when it's dry? No. Self and mutual allows that. So that's something we do with Gen 4. Next, stylus. How many of you have styli on your capacitive phones? Probably not many of you, and they're probably shaped the size of a crayon, right? They're not ideal for writing. So self and mutual capacitance, best of both worlds, lots of signal, but true multi-touch. We can do dynamic switching between the two and advanced algorithms to enable true 1mm stylus. So that's, you'll see coming on lots of new phones, ability to use stylus. And finally, hover. Hover is the latest invention. Again, a mixture of self and mutual capacitance together with advanced techniques. Now we can actually accurately track your finger as it moves over the top of your phone without physically touching your phone. It's pretty cool. I'm going to show you guys demos. Hover is out and in a production phone now, so it's real. It's actually getting integrated into the operating system specifications for the future, and it's going to be pervasive. What does Hover do for you? One, true glove support. A lot of cap guys talk about, we do glove, but then when you put it in the phone, it doesn't work so well. This is true glove support. So you can actually be in the winter using your ski gloves with your phone and the whole bit, not having to take it off while it's freezing outside. The other thing it does is mouse over. So we're seeing some new ideas from the user interface community. They're going, that's great. How many of you are on a web page? You're kind of surfing through, but that link is really dang tiny. So the first thing you have to go do is put it down, and you have to spread, and you have to zoom in so that you can actually hit that link, and not the link that was next to it, right? So that's one problem. So with Hover, you can actually do a mouse over functionality where your thumb is cruising over, and then it highlights, sees that link, explodes it, and then you can touch with accuracy. So we can tell the difference between a hover and a touch. And all that's because of self and mutual capacitance combined in the same device. So pretty cool. So waterproofing. Some of you might go, what the heck do I need waterproofing for? So this is a funny article I found recently. And it says, the finger nose stylus is, as far as we can tell, not a joke. So here's a guy who's sitting in his bathtub wanting to play with his tablet. And he says, dang it, my hands are all wet, I can't use my tablet touchscreen. So instead, what I'm going to do is create my own capacitive nose the size of Pinocchio, and I'm going to use my tablet with my nose. It's pretty funny. I've used this in a few presentations. I really like it. But it shows the importance of waterproofing. Waterproofing isn't about, let me put the tablet under the water while I'm taking a bath and use it underwater. But it's about physically when your hands are sweaty, when they're wet, when the screen gets a little bit of mist on it. Most capacitive touch controllers struggle. The ability to have self and mutual data, the same thing, allows us to do true IP67 compliant waterproofing. So very important. Here's the world's first IP67 phone. It's out, it's shipping in production today, and you're going to see a lot more waterproofing phones. There's actually quite a few in Japan already aside from this. But I'll show you a video of it, but it's the Sony Mobile Communications Xperia Active. You can fully dunk it underwater, see all kinds of cool stuff. I'll show you a video in just a second. Next, Hover. World's first Hover phone just launched. I don't know how many of you saw it, but it launched just a couple weeks ago. It's pretty exciting. It's bringing new UI stuff with Android, so you can see things like mouse over, you can see glove functionality, and so on. But hover's real. It's made its way into operating system specs. And for those of you developing apps, you can start thinking about the cool things you can do with hover versus just touch, and you'll see a lot more cool stuff coming. So, let me show you a couple demos real quick. We'll move on. So, I really like that one. It's pretty cool. But probably many of you have just had sweaty fingers and struggled. So, so that's hover. And finally, my time is up, but I will show you hover real quick. Tristan's telling me to go on. That was waterproof. There's a little marketing fluff at the beginning. So, a couple of cool things that you'll see coming, more of those things in the future, but I wanted to show you things in real phones rather than just on a demo kit, because it is real, it's not future technology, it's here today and you guys can start working on it. Alright, that looks like I'm out of time.
Great. Thank you very much. Hey, take it away.
Okay, thanks a lot. Okay, so I think I'm the youngest among all the speakers, and probably this is maybe the youngest sensors in the old sensor family. So let's start with a brief overview about Maxim. Just to give you a quick overview, Maxim is almost a 30-year company, and we have almost like $2.5 billion revenue. So it is Maxim is really specialized in analog solutions, analog integrated circuits, and our actual specialization is high integration of analog functions, because the integration is value. With integration you consume less power, with integration like you can bring innovation. So looking at the sensor space, I'll just talk about the sensor parts that Maxim has. We have almost like more than 7,000 parts. With the sensor, we have optical sensors. Right now we have MEMS motion sensors. We have image controller ICs. On top of these standalone sensors, we also have sensor interface products like for magnetic sensing, for proximity sensing, for pressure sensing, for humidity sensing, all those functions. So looking at optical sensors, like in all the presentations, like we talked about in the mobile space, looking from inside out, I felt that way, because we're looking at mobile applications. And I want to go over the optical sensor technologies we have, and that's already available in the market today. But I want to give you a brief overview about the outside thinking. So what people are doing with optical sensing in the world. Because as we go further, because these mobile devices are becoming a hub for us. So they can be the hub in this conference room, they can be the hub in your home, or they can be the hub in your office. So what people are doing with optical sensor worldwide. So the ambient light sensor. Okay. So the ambient light sensor, it is very basic. The ambient light sensor just measures the amount of visible light in the room. It's very basic. But the other thing is like our eyes, it mimics the human eye response. So the human eye response is very special in the sense that we don't see any infrared light, we don't see any UV light. So your ambient light sensor should be immune to UV light and infrared light. That's the challenge of ambient light sensors. So where do we use ambient light sensors today? So the ambient light sensors, for sure, we use in our smartphones, we use in our tablets, because in these devices, mobile devices, the display consumes lots of power. So the more power you save on the display, because if I'm in a dark room, I don't need to spend too much brightness on my display, so I can save power. Or if I'm under sunlight on a beach, so I want to see what is written on the screen. So it's like you want to increase the brightness. This is for mobile applications. So let's go through the other applications that I see, especially in the medical space. So when they, for example, when they ship drugs from one place to another place, people use ambient light sensors in the box. So if somebody opens the box, it registers that. So it sees that the medicine is exposed to light. Or in some other application, like we see the application with the bank safe applications. So the ambient light sensor is in your bank safe, somebody opens the door, and they see that. It's over. Or the other applications, like sometimes they use ambient light sensors as a proximity sensor. For example, I have a customer in Las Vegas, they use the ambient light sensor under the gaming table, so that when you put the chips on the table, they register that. And there are some other applications, for example, using especially one of the cool applications for ambient light sensor is the medical space for eye surgery operations. The patient is on the table, they turn off the lights, they're doing their eye surgery, and all of a sudden they miss a component in the room, especially with the remote control of the machines. So they need to cover the patient's eyes, look for the remote control, and they find it, and they lose time. In order to solve that problem, they put an ambient light sensor in the remote control. When the lights are turned off, the remote controller lights up. So you see the remote control. Then moving on, the proximity sensor. The proximity sensor alone is a really huge market, like it's more than a $2 billion market. But when we talk about the proximity sensor here, is infrared LED based. It's an active proximity sensor, so which is used in our smartphones today. We have the proximity sensor shining light, it bounces back, and we receive the light, so we sense our face or the cheeks.